Okay, so um, first a short update on the spin lock that we have tried last time, which didn't work. The version uploaded to Moodle is already fixed. There was a small glitch, namely the way the interlocked compare exchange works is that it doesn't return success, but it returns the value that was stored before the exchange was made. So if we want to use it, this is how it should be used. Here it's a bit different than, for example, how Qt does it, since there it really just returns success or false, because as you are providing the expected value, then you know implicitly what it will be if it succeeds. So it's kind of not really necessary for it to give you the ability to retrieve the last value that was stored. Of course, for the normal interlocked exchange function, which does not compare to anything, this makes sense, as you would want to have the old value before the exchange was performed. So that was our mistake last time. The other locking mechanisms, as you remember, worked just fine. And what we will be doing today is we will take a deeper look on the UI functionality that we have with Qt. We'll be using a library called QWT. Oops. Qt. As you see, it's on SourceForge, and it's a fully open source library. It's also under the LGPL license, so it is very liberal with regard to what it can be used for. And while it offers quite a few different classes, it is mostly useful for its ability to create nice plots. So here you of course just see one, but you can create many different plots with QWT, and we will take a look into it first. So I have already pre-compiled a version that should be compatible with our current Qt installation. So we need to remember where it is, as we will need to link against it and also include its header files. So it's here. And what we can also do is, for simplicity, we can create our next test project in this folder here. So then we have everything in one place. So let's quickly do that. We can close this and open a new window. And we create a new project. Go this time for Qt widgets application, as we wanted to have graphical components. We specify where we want it to be stored, and we give it a name, QWT test, as with our projects naming convention. Here we can leave everything at the defaults. Here as well, we only select precompiled header, as this improves the compile time usually. Press finish to create the project. Okay, let's quickly see where it ended up. We can, so now as you see, we have it a bit deeper, so we can move it one level up. This has the advantage that we can easier include our QWT and have everything nice in one place. Okay. So as you see, the project contains by default a form, so if we just run it, it would just show us an empty window. And what we can do here, since we would probably for simplicity would like to stick to the graphical UI designer, once it compiled and ran, we can add here a placeholder widget which we then can replace with our plotting widget, and this allows us later on to add graphical components more easily. So we first add a grid layout to the thing. We then also configure the main window to also use a grid layout. Then we just add an empty widget. And then we would want perhaps a button to plot something. So we can add a button here, and we probably also want to add a spacer to not have the button take too much space. So what the button will do, we will configure later in the source. The only important thing is that we will want to replace the widget, so we just call it dummy plot. Call it dummy plot, as we will want to replace it later with a plotting widget. And for the button, just call it button start, which will then do something. And what it does exactly, we can of course then also define later in the code. So one more thing that we should add is for starters we could add a helper class, although we could perhaps just demonstrate it. Let's first demonstrate the plot, how it works directly without digging into already creating something more complex. So let's start from the simplest of examples. So we go back to our main, to our class file, this one. Okay, and what we will need first of all is a lot of includes from our QWT. So hash. So we could also configure. We first quickly look where all the includes are. So as you see, we have here the source codes, and then the source and the header files are at QWT source. So here we can go to our project properties, C++, general, additional include directories, and we can add. I think we need to go one level up. Source. If this works this way, so we actually don't need to go one level up. Let's just stick with this. This should allow us to easier include all the necessary files, which is quite a list. So let's start with that. Does it have the right includes? I don't think so. QWT. Nope, it doesn't. Okay, then let's include it. Oops, then let's include it manually. Stupid autocomplete is. That should work. We can try a different strategy. We can give it a path relative to the solution directory. Then we know exactly where we are, because the solution we have stored here. So from this folder, it's just QWT and source. That should ensure that it works. Maybe it wants. Yeah, it works. This way it works. So we include QWT plot, of course. Plot, and we include quite a many others. QWT. Type QWT plot group. Nope, it's fine. Then we need QWT plot page. The IntelliSense is somehow not helping us with the autocomplete. QWT, no, it works. That might be enough. Legend. We want And the legend for upload might be enough for the start. Good, so we have hopefully all the main includes which we will need. We will also need to somewhere define all our variables, so let's start with that. Go to our header file. We should pin the files that we work on most so that they don't go anywhere. Okay. So we create a new plot. It does not take any arguments for the starters. Now we want to install it in our existing UI, so we can use UI punct what was it? Dummy plot. No, that didn't it compile? No, it already built it. Let's quickly rebuild our UI file so that it updates all the new members, that we have all of them. Right. Wasn't it saved? It should have been saved. Do my plot, yes, UI. Again, build. Why is that not up to date? And let's build the whole project. It will not, because we have here the yeah, okay, this is because it misses it's missing the library that we will add later. Y punct. Why is that not compiling the UI properly? Yes. XML. It's in the file. Let's build it again. Now it did it. Dummy plot. Parent widget. Layout. Replace widget. Dummy plot with this one. Okay, now we need to add the library, since we have uncommented the constructor. Without the library it will not build. Linker input solution there slash let's see where we need to go. QWT, I think QWT again, and we have a x64 debug build, and we have the lib here, lib, yes, so, oops. Okay, solution. Okay. it, and then we also need to copy the DLL into the right location, otherwise it will not run. Zack, here. Our project needs to be able to find the copy it. I think it's time to reboot the virtual machine at some point again. It's getting slow. Zack. Okay. So as you see, it added the plot in where we previously just had our empty placeholder. This one. It's actually quite a nice mechanism to add things which are not represented in the graphical UI designer. Technically, you could write a plugin for the designer that would allow you to use your own classes inside it directly, but that's usually not worth the effort. And so the way you do it is you take the widget you want to replace. You get its parent widget. On the parent widget you get the layout, and on the layout you have this replace widget function, which just wants to know which widget you want to replace with which other one, and voila, it does the replacing just fine. So that's what we have done here, and now let's improve our plot. So we have created it. Now we probably would want to set some style to it. So plot set style sheet. That takes a string. So let's give it one. Zack. Let's say we want red will be 0, green will be 50, and blue will be I don't know, 100. Or we just use a color name that should also work fine. But now that would be for the grid, so let's do gray. And background color, let's go with black. And as shown before, you could also kind of use the RGB nomenclature and just specify the individual colors. There is also a set of named colors that like have an existing name that you can just write there, like gray or black, and a couple others. So here that does not look that great. Let's quickly see which other colors we have to our disposal. There is a list somewhere for Qt with all the colors available. So I mean, you can also use the hexadecimal codes like in HTML if you want, if you prefer that. That's dark blue. Dark blue sounds great. Sounds good. So let's go with dark blue is, I think, a nice plot background. Let's see if that looks better. Of course, you could also just allow the user. That is not good either. Okay, so let's go with red 0, green 0, blue. How much blue is good? Let's try 50% blue. That is too much. Let's try 90. Yeah, that looks nice. And the gray is a bit too gray, so let's light gray. If it knows it, if not, then we'll just use RGB again to specify a color which we really like. Yeah, that looks nice. Okay, so we have specified our style sheet for the main plot elements. We could add a grid. We already included the right file, so let's do that. qvt plot grid then okay. We don't need to define everything oops, typo grid. We don't need to define everything here in our header because for some of the elements we don't need to access them once we have assigned them to the plot, and once they have been assigned to the plot takes ownership of them. So at that point we also need to care ourselves to how we dispose it, because the plot does this automatically once it gets deleted itself. We need to specify a pen so how we want the grid to be. So one of the arguments, first one will be color again. So let's go with Qt. Let's support white. That should be here we have white. I don't have white. Then let's go with color from RGB R255. That gives us white. Then we need to specify what pen we want. First we need to specify, I think, thickness. Width, yeah. So let's go with very thin, so 0. Even though 0 seems like thickness of nothing, it will still give us some thickness. And then we need the type of line. So let's go with dotted line. 1D dot line. Okay, we have closed both, and now we of course need to attach it to the plot. So attach to our plot. Zack. And we have now our grid line as well. Maybe you should make it a bit grayer. 192. Let's see if this looks better. It's always a bit fiddly to find the best value to use to make things look just as you want it. Yeah, that looks good. So let's stick with that. Okay, so now what we want is we want to plot something on the plot. Since we already have it, we can start with that. So to plot something, we need a curve. So we'll also here need some structure to hold our curve. So for that, let's create struct as curve, Zack. And it will first of all keep an object of type QWT type plot curve as a pointer curve. And what would also be good is if we use the object to store all the other data which will be required. So we want as size t a size of our data, and then we need the data points. Although we could improve that. Actually, we could improve that a lot. We just need to include std vector include small v. So what we want to have in the end are two arrays of type double with x data and y data, and if we use a vector here, then this way we don't need to do the memory management ourselves. The vector does it for us, and we will just put the pointer into our plot object. And then of course what we will also need is something to hold an instance of our object. So for starters we could just call it test curve 1, Alternatively, you could of course keep it, for example, in a QMap. That's maybe nicer. As key, we take an integer and then the curve. Then we can have as many as we want. So let's maybe go with that. Okay. So now we will need to create such a curve, for which actually it would be nice to have a function, so that we don't need to all the time invoke the same functions once we want to create multiple curves, and we will want to create multiple curves. So let's call it void add curve. It will take our ID and it will just create one curve of the given ID and not do anything besides that for starters, although what we might want to specify also is color and pen style. Since we want to be able to tell our curves apart. And for later, since we will be adding a legend as well, we should add a const string reference title. That is everything we probably will need. So let's write quickly our function. So, and one maybe my modification, I will make it boolean, and I will make it return false as failure if the ID has already been used. So obviously we cannot store multiple IDs of the same type in our map. So if our map contains ID, then return false, and else return true, as we don't expect any other things that may go wrong. So as curve 10 pink, and we need to do this as a pointer to a reference, since we want to be able to later change the entry in our map. So what we basically do here is we get a reference on the pointer which resides inside the curve's map. This way, when we change our p curve, it will the change will be reflected in our curves map directly, instead of needing to assign it later on, which would be the other option, that we create a new curve here and then just insert it. So alternatively, we could also just do this, and further down insert. The nice thing about STL is that it takes directly key and value into the insert file. The nice thing about Qt is that unlike STL, it takes just directly the key and the value as arguments for insert, and you don't need to wrap it into a STD pair object. That is kind of nice. Okay, but anyhow, so we create a new curve. Then we need to create the plot. Curve because that is a bit redundant. New qvt plot curve. That one takes the optional title as an argument, so you can also just not provide the title. Right here, and then on our curve we can we don't do anything because we don't have yet anything to set. We just need to attach it to our main plot. So like here, zack, and that's it. So let's use our function here, add curve, ID null, color qt red, comma qt solid line, and we call it test null or plot null. We can also give it ID 1 and call it just curve 1. Yeah, that's a nice thingy. So at this point, of course, it will not do much, since we don't have any data, so it has nothing to show. But we just quickly run it, and as the next step, we could actually add the legend, since when it's attached, then it should automatically be able to properly show at least the legend for whatever it already knows there is. So we add the legend here, qvt legend, then make new legend. The nice thing is that we don't need to do much with the legend, we just need to initialize it the way we want, and it will once attached to the plot do its thing automatically. So we don't need to tell the legend about new curves, their names, etc. This is done all automatically. So we just need to set the style sheet. Set style sheet. Again, it's a string. We just want to specify color. What color do we want? Let's go with RGB again, and let's start with white. Maybe here it will look nice. If not, then we change it later. Nope, this time it's different. Plot insert legend, and we should tell it probably where we want it to go. So let's say qvt plot, the large W and large P. No, small w, large P. And want it to be bottom legend. We don't want it to be anywhere else. Bottom is a good place for a legend. And it says curve 1, but we messed up something because it's showing just a black dot. So right, we have not assigned the color anywhere. We forgot to assign the color and other things. Set pen, q pen again, brush font color, comma 1, comma style. Now it should show us the legend properly, or rather show us this curve in the legend properly, and voila, it tells us how it would look. So now it would be time to actually draw something. So since we already have our button, however we called it, I think button start maybe. Yep, we called it button start. So let's go quickly copy the name. Let's here, actually we can do it inline. So with the new Qt, the nice thing is that we can in principle specify inline, so sender SUI comma that we can specify using lambda functions slots. We don't need to always create a function for a slot. We can just have a lambda function as slot. Rest, comma this, comma lambda function with an suck. Is it complaining? Right. Okay, and I would suggest that we just start a timer which will very frequently add new data to our plot. So we need to go to our header for the timer and create an ID, and let's call it timer, and small t looks better. We can initialize it with 0 since we don't have it at the beginning. We also need a function. Wait, what was it? It was something like timer event. Let's quickly find it. Is it not taking us to the definition that no, it took then we need to go to object once more. And here we have somewhere definition of our timer event, this one, timer event function. So we define it here. Sorry, we don't need the body goes somewhere else, zack. The body will put here. And the way this works is on every timer that is started for this particular object, the same event function is called. So the way we can tell them apart, whether it's ours or some other, is one we can take from the thing here, ID, timer ID, and it must be equals to our own timer ID, which we'll set in a second, or rather, when it's not equal, then we just return because it's not our timer. Usually this might not happen if you are not using some other more complex classes that would create timers on your object. So this is more interesting if we ourselves would create multiple timers and then would want to be able to tell them apart. But since we're only creating one, then let's go with this. And here we make timer. This equals start timer, and we provide some increment how often we want it to create a new dot. Let's go with 100 milliseconds. The rest of the arguments is not relevant for us. You can change the timer type, so if you would want only 10 milliseconds or 1 millisecond, then we probably should switch to a fine resolving timer instead of using the coarse timer. And one thing we should not forget is to stop the timer. So if this is not null, then kill timer with our ID. And we check whether it's null because we might have not pressed the button. By the way, we should check whether the button was already pressed, because if it was already pressed, then we don't want to create another timer once more. Okay, and now of course we will here want to add points to our curve. So one thing we need to do is we need to find our curve. So let's go with this line just without the reference, since we don't need it, and we just have to specify the 0. I mean, alternatively we could of course implement a function that gets us a curve by a given ID, but that would be just a small wrapper for this single line, so this really is not necessary currently. So let's go with xData, push back. What do we want to push back? Yeah, we want just to increment it by 1, so let's just, well, and we need a value, so let's just push back the size plus 1. So basically what we are creating as a x-axis is just 1, 2, 3, 4, 5, 6, 7, 8 and so on, as long as it goes. We could use any other increment. Since it's a double, we could have 0.01 increments. We could use the current time as an increment. So for example, when plotting something as a function of time, obviously that would be a very useful feature. But for now, let's just go with the numeric value of the current x index, and then of course we need to set something as y data, again push back, and here let's go with just entering a random value number. The interesting thing is, if you don't initialize your run function with calling shunt with a random seed, then every time you run it, it will look the same because it starts from the same number and it's already the same algorithm. So usually it would be important to initialize it with something non-unique. For example, you could go with what would be good, the current time, date time, current milliseconds since epoch. This is something that will not repeat that often, so it will at least look random, since it's just a pseudo-random number generator. It does not generate true randomness, it just creates somewhat randomly looking output given a seed, and for the seed, for a given seed, it will always create the same series of values. Okay, and one more thing we need to do, since pushback might change the internal memory object inside our curve, simply by the need to reallocate a bigger memory block in a place where there might be enough address space left. So we need, each time we change it, update our set row samples, update the curves pointers to point to our data. So we go with x data punct data y data punct data, and then it wants to know the size, and they both have basically the same size, since we always add elements to both. If we would only add element to one of them and forgot to add it to the other one, that would cause a problem. So let's see. We probably also should replot it. We didn't do it. I think it will not. No, it crashed actually. Oh right, it crashed. I think I used the wrong ID. That was 1. We don't have a 0. We added it as ID1 here. So obviously 0 wasn't existing and it crashed. So let's add a check. If this does not exist, then return. Yeah. But now, since we also have the right ID, it should run just fine. Yeah, we were missing the replot. The thing with replot is that it takes quite some time. So if you have a lot of data, it is good. It's a good idea to only replot, for example, 4 times a second or even less, while updating the data as often as you need. So now it is working and is plotting random numbers. And we could of course add multiple plots and add multiple random numbers in different places to make it look more interesting. So we could quickly do that, but first we will move the body of this function here to another helper function. Add plot point int ID, and now we can do it in 2 ways. We can either do it such that we only can provide the epsilon value, and the x value will be auto-generated, or we could always provide both. Since at this point we would want to do it without having access directly to this data, we wouldn't know which index to use. So we will just only provide a new epsilon value and let the x value be auto-generated. Okay, snack. Like with the other helper function, we'll give it a small safety check. Just this time it works a different way around. So if it does not exist, then it fails, as we have seen. When we try to do it while it exists, then it creates issues. So when we try to use an ID which does not exist, then it crashes. So we don't want that. We want to avoid it. And this helps us do it. Replot we will take out from here. We will replot later, and we just here can now add plot 1, rand. Oops. And what we want to do is, since let's say we want 2 plots, and we will add here a second plot, 2 green solid line curve 2. Right. Okay, that's already good enough. Let's run it. And it works as expected. So now the plot is still a bit basic, so you cannot click into it, you cannot do anything except resizing. So we will, next thing we will do is we will try to improve on that. We can of course also try to improve on this replot mechanism, but for now I think this is not necessary. If we see that it gets really slow, and we could for example increase the speed here and see how slow it then will be. Now it should plot 10 times more points. So at this point I expect it's not so bad actually. It's using probably a lot of CPU here. Threads. Yeah, so one thread is completely using a whole core of the system, so this is not ideal. And you see it's also hanging, so it would be good to improve that. So since we are plotting points so fast, let's add some mechanism actually to slow down just the replots. The data are still there, they will not be shown so often. So what we can do here is we could either just count ticks of the timer, which actually is probably the easiest way. Let's just do it. Int so we create a variable, we call it tick count, and if tick count plus plus modulo 20, that will be 5 times a second, is equals 0, then replot and reset. Oh, and we should of course do it like this, since we will, if need be, then discard the value anyway. So that's more efficient this way. Just slightly more efficient, but still more efficient. It probably will not look that smooth, but in turn it will by far not. Yeah, you see it is kind of updating in blocks, but it should use much less CPU. Yeah, as you see here, it's just using 8%, 9%, up to 10% of one core, instead of entirely taking a whole CPU core for its own. So this is quite a worthy improvement. Okay, so let's see what else we could add to make it better. So as already said, one nice thing would be to be able to zoom around, and there is a QWT zoomer object available. So let's add it here. QWT plot zoomer. Okay, but since the object, so it has some default behavior which we might not necessarily want. So what we can do is we can create our own derived improved zoomer. So let's quickly do that. QWT plot large P liquidity plot zoomer. Yep. Okay, so first of all we need a constructor. Yeah, we need to specify for which axis we want it to work. So comma, then we want specify a canvas. Then we need to, these are the default parameters which the thing here wants to have. X axis, Y axis, and the Q widget. So we just pass the arguments to the parent constructor. Zack. It looks better if we break this into a new line. Now we can set a few options how we want our zoomer to behave. Set rubber band. Set rubber band pen. So we can select which color it will have. Q color. QT. Let's make it green. Set QWT picker active only. This means it only shows the tracking tracker mode. That only shows the rectangle on the tracking for the mouse position when it's actually in use. Set tracker pen. We also need that. Let's make again white. Okay. And we want to also define how we want the mouse buttons to behave. So set mouse pattern wt event pattern mouse select to qt no button qt control modifier. So this will require the control key to be pressed down. So let's write down what this does, since it looks a bit cryptic. Control plus right button is what triggers this setting, and what it does, it will zoom out to full size. And then we do the same thing for another option. Mouse select 3, comma no button. We don't need anything specific. So if we click the right button, it will zoom out by 1 position. And for these we would not have needed an own class, but the next thing it does, we want to override one of the functions that is built in. Event filter event filter, looks like there are no typos, and if we don't do anything, then we want to invoke the parent class's event filter. Oops. So let's start with this. Okay, and now let's do our own code. So we want, of course, the object needs to be specified. There are events which might have none, and the object must be of type parent widget. Okay, and now we can switch the event type. So select on which event we want our altered behavior to take effect, and we just want a double click case q event mouse button double click suck. And for this one we want the altered behavior, so we need to get a mouse event then we need to cast from our existing event to our mouse event. Now we check if it's the right button of the mouse, since we don't want to react to both buttons when we want the left. Qt left button. Okay, so it's a right double click. Good, and we want this to behave the following way. So if mouse modifiers equals qt control modifier, then we want zoom in, and if it's not, then we want zoom out by 1, and we return false since the event was handled. If we would not handle the event, we would return true. I think I should check the documentation on that. So let's add it to our existing project somewhere here. So my Sommersternplan new Sommer. We need some so qvt dot x bottom and qvt dot oops y left. Since we could have also different other axes in the plot, we could have one on the left, one on the right. We could have also an axis on the top, so we need to specify. Then we need, of course, to give it the canvas. So plot canvas, so that it knows on what it can draw its helper things, and then we need to connect, and that should be already everything, I think. Wait, it's complaining about something. Oh, it says it's not accessible. Page chart. Public. We forgot to define the constructor as public. That helps. Is that all we need? We will see whether it's all we need. I was thinking that it needs some. Yeah, so if we zoom in, some things are not yet working, so we cannot move the plot. So let's also add a plot magnifier so that we can scroll the mouse button and zoom around. What we would want also would be the ability to move around with our mouse, so that we can go to places that we want to have. So somehow we have. I also need the magnifier. For that, I don't think we need an own object, so let's just go with adding it. qvt magnifier stamp new magnifier, and we need to provide it a canvas to connect to. Let's quickly check if that is everything that's needed or if we forgot something. Yeah. We can zoom out and with the mouse button, but we cannot move it yet. What did I forgot to make it movable? Right, we need a panel also. So qvt.panel. What does this one? That of course needs a canvas as well. and we want to tell it how it should behave. So set axis enabled. HP x epsilon right, comma. We want to disable the ones that we are not using, and the other one will be stop x top, and we want to tell it which button to use. So mouse button, Qt middle button. Right here, that should be everything. We forgot something. Yes, we forgot. For the magnifier here, zack, we want to tell it not to use any mouse buttons. We want it to work only with the mouse wheel. No button. Okay, let's run it. Let's start it. This works as well. Now we can move it when we can drag and drop it with the middle mouse button. One thing that is a bit unnice is that we lose the ability to automatically progress the plot, so that we would need to reset or add a reset function. So once we started zooming manually, once we are stuck with having manually to zoom into the area that interests us, it will not longer automatically move the plot. To demonstrate it quickly again, that might be a detail that we would want to fix later, because this is actually quite nice. Of course, it then always rescales to show everything, which at some point would also not necessarily be ideal. So what you might want would be to only show some amount of the data and have the plot like just show you a window and then move the window as it comes along. So it as you see, it's a very flexible library, but it also needs some extent of manual intervention to make it do exactly what you want it to do. There are, for example, objects that you can add, like Qt scale draw, to define how the scales are drawn, so that you can have an own function. For example, if you would use a time value and you don't want that the number there to be just the number of milliseconds since 1970 something, but instead to the actual date as string, then you would create such a own data scale object which would do that. We could actually demonstrate this as well, because I think this is quite nice to have a custom scale. So here, where's our function? There it is. Instead of adding just the element count, we would want to add date time milliseconds since epoch. So this is 197 and then I don't remember, something, probably the first and the of the January or something like that. Okay, we first need to but if this offers us this thingy, then it should work, but it doesn't. Alright, okay, so now we can quickly see how this will look. It will just give us very large non-descriptive numbers which are kind of useless, but that's the whole point. As you see, it just gives us a very, very large number, and that's it. So obviously this is not interesting as a scale, but if you want this to, for example, plot the actual time, then like the time of day, then if, for example, if you are logging let's say a pressure or a temperature chart, then you would want to know which time of day it really was. So you really want some human readable time for that. So let's quickly do this. Class it's date. Let's call it cDate scale because it will be a scale which shows date. QWT scale draw, and there we should not forget to make it public, so otherwise we couldn't instantiate it like before. But actually we don't even need the constructor, we just need one function, QWT text label double value stack const. So this function, and we need to include scale draw. Was it scale draw or was it plot scale draw? I think it was just scale draw. Let's see. Oops. QWT scale draw. Yep, oops. QWT scale draw, so now we have it. And before we fill in the function, we'll just quickly install it. Maybe before the grid. Yeah. So mplot set axis what was it? Set axis schedule. Set axis x schedule new. Nope. First we need to specify which one. QWT plot. Oops. X bottom. That's the scale we want to replace. New scale draw. And now what it will do is for every tick it wants to write, it will call our label function here, and this will return. This can return whatever we want. So we could, for example, return blah. This is of course kind of wrong since it's not quite what would be useful. Wait, why is it complaining? Doesn't this have a function of type label, or did they change? Oh, that was removed. They don't have label defined on this anymore. Okay, so which other function we have? Move. That is not so great. The older version of QWT had a really nice function called label, which then was just called each time you wanted to draw something, but apparently they have. I guess we will need to use a draw label instead. Let me quickly check if I have a some. No, I don't think so. Yeah, that we will have to do like this, I guess. It kind of gives us more flexibility because now with draw label we can actually really draw anything we want, but the downside is that it's more work. Draw text. I need to specify coordinates. Well, I guess at 0 and 0, and let's test it with blah. If it will now, so my expectation now would be that it will just write blah for every tick in our scale, and then we can continue from there to improve. Nope, it doesn't work. That is not great. We should have stuck to the old version. Let me quickly check for an example. Yeah, but the old examples, they all use label. They don't use the newer implementation. And, let's see what else we can do. Text options, flag, correct, probably set pen. Let's set a pen for this. I mean, the other options, of course, we can just call draw label of the parent function and then just see that this doesn't work. So what we can do, I should have tested that up front. I just assume it will work. You can just take a look on what their implementation is doing exactly and then just adapt it, since everything is open source. That's an easy, cheap way around our small roadblock. So this is their implementation. So we have label. Wait, there is a function a tick label. Then that is even nicer than they just relabeled the label to tick label. Did I miss that? Oops. Draw tick. That's probably implemented on the parent here somewhere. Tick label, yeah, okay. That simplifies things. We just need to can go back to our initial plan. We just need to rename the function to its newer version, which is this. Takes font, which we don't care, and string. It's a big string. Wait, huh? Doesn't that take a? We might need to include that actually. Perhaps. But it doesn't seem like it would be defined anywhere. QWT underscore QWT underscore text h. Now we have it defined. Now we can see what it takes as an argument. It takes just a Q string, yeah, so now it's fine. We're just missing an include. But it is not using this. Wait. We have set it. Did we compile this? Let's quickly rebuild it. Why are we not using our new class? We are setting it here. That should be fine. Why is that not being used? We can quickly add a small interception to the constructor. Why this is being used, this is not. Oh, I think I know why. I think they unfortunately changed this a bit too much. So the idea is to get tick label no, it has the label function. It's not calling the tick label because this is not a virtual function. That's why we cannot override it, but I'm just seeing that it still has the label, so I'm not sure why the IntelliSense before was complaining that we cannot use it, because apparently it still exists. So it was not even renamed, we just had a problem. We should have just tried compiling it as it was without trying to fix the error, just because IntelliSense was showing a red underline. It probably was complaining, now it works, we have fly everywhere. It probably was actually complaining about not knowing what this is. We don't need to specify virtual if the function is already specified as virtual by the parent, in the parent, by the way. But now let's actually return a proper value. So qDateTime from ms since epoch double value. Oops. So here we can re-get our time, and now we would write the whole date, which we might not want. Maybe we just want the hour, so let's go with time, and then we can convert it to a string, and we can specify qt a format, right? So now it should write the hours, minutes and seconds from the start. In this case, of course, it start at 1. Yeah, now it works fine. It's 16 o'clock, yeah. So as you've seen, this is quite easy to create. Yeah, and apparently if we do something that makes the timer not fire, like for example resizing the window, apparently stops the timing, the timers. This for some time, then we get these jumps because more time passes before new data are created. So if we would want to avoid this behavior, we would need to create a new thread in which then we could run independently from the main window. So this is one small limitation here, that we should implement it in a more sophisticated way if we want to not lose this nice if we don't want to lose any individual samples. Let's say it like this. So was everything clear until this point? So at this point, what you would be able to do with this knowledge is to create your own plots with as many lines as you want. So as you can see here, we can add them 100 if we want. Actually, let's quickly do it. For though maybe not 100, let's go with, I don't know, 16. The main problem is that we don't have colors. Well, we have colors, but we would somehow need a way to go through them. We'll think about the colors later. Now everyone will have the same color. %1. Good. And then we do the same thing here. We're just adding plot points at I. Yeah, as you see, we have a lot of red lines. That's kind of useless. So what I would think is a good approach is we create an array of useful colors. Actually, there should be, like, if we go for Qt red, then we have like black, white. Okay, let's light gray, red. Red seems a good start. Red, green, blue. So how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have 12 colors starting with red. Okay. So we could, we could go here, go red plus I modulo 12. So we'll just reuse the same colors over and over and over again, and then for here we can use different line types. So we have 1, 2, 3, 4, 5. We have 5 line types which are useful. So let's, how do we do that? We can I divided by 12, and then this modulo 5, and then wait, which one was the first one? Pen style solid line. Qt solid line plus we need to do some casting. Was it pen style? That was just pen style. T pen style. So it will create the first 12 in solid line, the next 12 in, what's the next one? Dash line, the next 12 in dotted line, and so on, and up to 5. So we could actually create 100. That's too much. Why not? Just to I need to update it further below to or also feed the other ones with data. That actually failed completely. The color just became always black. That it was not what we wanted. 2 things to fix. So this one here. Zack, and let's see what we screwed up with the colors. Well, I modulo 12 would give us numbers from 0 till 12. These should just have numeric values, 7 plus and so on. But that somehow failed. Just let's quickly check whether it really was the color and not the... Yeah, I didn't like our color trick. Technically should be right. Color. Sorry, Q color. Probably with some sort of conversion error, and this thing is of type Qt. I think it saw it as an integer and then it tried to interpret it as an RGB value stored in a 32-bit integer, and that's why it worked, but not. It took the value. Yeah. Now we have the different colors. As you see, the colors are repeating, but once we start plotting, okay, that is just too much different things. But you see some are dotted, some are straight lines, and also what you see is that we have the CPU is just not powerful enough. We are just where is it? Qt here. We're just fully exhausted with the work, and then we get this gap. So it does its work, and then so much time passes until the next tick that it's actually getting slower, as you see. The reason will be that each time it needs to increase the size of the oops, that was the wrong button, of the vectors that we have. So we could improve on that. Add plot point, no, was here, add plot, yeah. Curve, X data. We can reserve a certain size. Let's go with 4000 data points, X and Y. And now they should all be equally distant. Actually, that should improve a lot. We can probably set the grow size so that it will try to grow in larger chunks. That would improve as well. It's still getting slower. No. It makes the gap not when it's increasing the size of the vector, but when it does the replot. And since it has more and more data points, it's getting slower and slower. That's the problem. But now, as you see, we have zoomed in, so it doesn't need to draw so many lines. So it's fast. So if we hide it and then go back, we see that the before was actually quite nice. The replots are just wasting so much time. So what we should do is we should move our data update. Don't need that. To move our data update really into a different thread. So let's do that quickly. My data source, my data source, thread. My data source. Alright, we don't need this anymore. Probably we also don't need the constructor here because we probably will only need the void run function. But what we will need is some mechanism how you would push the data from one thread to the other. So first of all, MP data source. One thing you might also notice is that I'm using here this RSWrite class before a type, and here as well. And for example, those types are nowhere defined in this header. So the idea is that if you're using pointers, then you can use a so-called opaque pointer. We'll just tell it will be a pointer by basically saying that this data type as such belongs to a class, and it doesn't need to know anything more about the object. So in such scenarios, it is fine if the definition of our things is done later on. This is a quite a nice trick in C++. Okay, so we have here our button, we have here our curve. Well, let's say we still want 100. I mean, we don't want 100, that is too much. Let's quickly revise our color choices. Let's go 1, 2. Let's just go with 6 of them. And for the lines, let's just go with the first 3 types. So this divided by 6 and this times 3. Right here, so 6 times 3 is 18, so we can have 18 different lines before the whole thing starts repeating. So we will not need the timer since we want to use the thread. We need to create it. New see my data source, zack, and here if wait, something's not completed. Yeah, public. We need to define it as public in order to be able to access the different members of the queue thread. Is running. So if it's not running, then start. Start, and here we shouldn't terminate threads, we should gracefully close them, but for now we don't care, so we just kill it. And now thinking about how to get the data from one place to the other. So as you may remember, we have this signal and slot system, which usually is quite nice, but it has significant overhead. So a method where we would invoke a slot from our thread would, for every single data point, if we have 18 data points times 100 times per second, so it's like 10,000 data points per second, so 10,000 invocations above, even almost 20,000. That would not necessarily be the best design. So what we want to do is we would want to do it somehow, let's say somehow more more elegant. Also, I will start the timer because we still need it in order to perform the update, the replot. So the timer will be running. It will be now always running. It will not be optionally started, but it will not add any data. Adding data will be the task of our thread. The reason for that is that the replot function needs to be called from the UI thread. We could actually call it from time to time from our thread using a signal and slot mechanism actually, but I think to keep the timer in play and not get rid of it, since it is a nice tool for other things as well, we should probably go with this option. What we could do in fact would be to set a flag where the data actually changed, and if the data changed, only then update here the tick count. Just thinking how to make it the most elegant, because the main problem is that this curve is actually holding a reference to the actual raw data pointer. So if we change it outside, it might cause issues. So you would either need to lock the UI thread each time we want to make an update, or what we could do, which probably is the most elegant option, is that we would either accumulate data and set them in batches to update in the main thread a lot of points at once they are batched together, or we could actually do it in our timer function, the batching together, but although that would probably also be not the fastest one. No, that is a good option. So this would be one option, and the other option is that we would have like a whole copy of the data, and then we would just swap around the different copies. So we would have one copy in our thread in which we are writing continuously, and then we take snapshots, so say, of this data, and then push them to our main UI thread. Or the other way around, we make the data being kind of pulled by the UI thread, which probably in this case would be more elegant. So I think what we will go with is that we will pass our map here once it's created to the thread, and inside the map have here and inside the structure here have a second set of x and y values called temp, which will be continuously filled by the thread, and which we will be from time to time pulling into our data and merging them with our existing data in our UI thread. So we need a mutex for that, actually maybe even a q read write block. Okay, so we start the thread here, but before we start it, we will need to give the thread our map, or we can just give it a list of those objects. That is more elegant, so let's go with that option. Call this as curves. Okay, we have defined S curves here inside this thingy. So let's make this into an opaque pointer as well and put it here. Now it's available globally. Okay, and we are missing a semicolon there. Zack, where were we here? So before we start the thread, we will curves is equals curves values. Just want a copy of the values. Right, and we only do it if it's not yet started. So if it's started, then return, and else we do the initialization. So if you press the button again, it will have no effect. Only the first one will. Value s multiple. We want all values. Okay. Right here. So inside our run here, we should add a loop. While one that will run forever. Actually, we could add a variable which would allow us to stop the loop. Let's do that. So this needs to be true to run. So here we need to set it to true. Where was it here? And here, instead of actually killing the thread, we can set it to false and then wait for it, because we expect it to terminate very fast. So we have already improved here on our code a bit. And now inside our loop, let's sleep for 10 q. Let's use the q threads as sleep 10. Okay, so we have our sleep here, and now we can do something. So we have our own list, so we can access it at any time. So for each p curve in curves, cool. Cool read lock, no, write lock. We want to write cool. Read lock, write locker, cool. Right. Write locker that wants a pointer to this thingy. Also, I just see I used little l. I prefer it to be capitalized. Oh, I don't want to use a prefix in a structure. Okay, so now we know we have exclusive access to the data members. So now we can go to here. No, not here. There. And just need to remember to push back the data onto our temporary object. What was it? It was just a random value. Okay, so this will be executed in nice in proper time steps. I'm just thinking about one thing, namely when we lock this, but it should be fast enough. So there can be a small delay if the other thread is keeping the lock on our lock. Then of course this will also kind of get delayed. So it is not. So what we need to do is to ensure that our other thread will be very fast with regard to releasing this lock. But I think we can ensure that, since we will not be plotting or doing the replot at this point of the operation. So we can copy more. Let's go with that. Zack. Then we want a read lock. It's kind of pointless to use a read-write lock if you only have two elements that are reading and locking. The ability to use a read-write locker is only interesting if you have multiple things that are reading at the same time. but I used it here just to demonstrate it, that it can be used, since it's a nice feature. So once we have our log, what we want to do is we want to x data punct. Let's see how we can we push back more than one element? Nope. We could only swap. We don't. We will need to do it, so to say, manually. So, isn't there really a better way? I don't think so. I mean, if there would be a function, then the function internally would also do it, kind of manually. We start with the AutoX. In curve xtemp. Push back x, comma, and then we just clear this, and then we do the same for y. So y, good. That should do that. The locker gets released once we exit the scope, so once we decide to do the replot, it should no longer be held by anything, so our thread will not be hindered. These things are reset, so they are clear. Yep, looks good. Let's try it. Oh no, we forgot something, we forgot something very important. If we try it, it will crash. We forgot to update the pointers here. Right here, curve, something. Yep, good. Let's run. Now if we resize the window or do something that locks it for some time, it doesn't do anything for some time, but then it always still has the full complement of data that that it had before. Again, we can try our zooming. It's always zooming both axes, which might not necessarily be what we want. This is a behavior that also could be changed. And yeah, voila. So as you see, it is a quite powerful library. In principle, you could also try to set, I think, logarithmic scales. It supports that as well. So as said, it's very versatile. It also the library also contains a few other elements, like knobs that you can rotate and alike, but those are, in my opinion, not really that relevant. So normal simple sliders you have in Qt already. The most important part of the library is really the ability to make easily really nice plots. Any questions? No questions at all? Okay. Yeah, so then I would say it's time to think about some homework. And I think work 19/10/2023. And I think what would be a good homework for the today's lecture, since we were using the QWT library, would be to create a small program. I mean, you can use the QWT test as an example, which would not write random data to the plot, but something that makes a bit more sense. So for example, a sine function, and then have a few input fields where you could, for example, specify the frequency and the amplitude of the function. I think that would be a funny and not too complicated endeavor. So QWT. Doesn't need to be always sine and cosine. Sine, you can plot others if you want as well. For which a combox where the how many functions you select is up to the user. So we don't want too many, it's just enough to have this for starters. Right, for each curve add a combox with the function to be picked. And the two the frequency and amplitude. So the way this should look, we can quickly add one of them. Oops. The combo box. Then we want a line edit and another line edit, and technically you probably also want a spacer. Yeah, so this should be bigger, this should go there. We don't, then the button will grow. That's the best approach. We have one spacer here and we can enter thingies, and then just add a few of them. You can have a hard-coded amount, and then actually we should add labels. That makes it look better. Label. On the side we cannot just change the name, but also all the different parameters, like also the default texts and frequency and amplitude. And the idea is that the user can fill this out and then press the start button, and the thing just starts plotting. And it would be good if here the values could be changed, and then the changes would in real time be reflected, so that you can change one of the frequencies and see how it looks. The value changes should be applied in real time. Any else things that we should mention? Plot and some optional homework maybe. That is nice. So for example, you can add two sinuses to each other. Oh, we forgot the phase shift. But let's say the phase shift doesn't matter. If you have two sinuses with different frequencies, that will already give you quite a nice peaking curve. So and how you implement this is up to you. So one simple option is if you just have, let's say, four baselines which can be configured, then you can have just like hard-coded options with checkboxes where you can just select or with radio buttons where you can just select individual groups and add them together. And the other mechanism what you can do is you can add something that you actually have a button which you can press, then it will show a window, then you can select what you want to add, and so on and so on. So you can make the optional part of the homework as complicated as you wish. Good. I would say that is it about this part of the library, and homework we already have as well. Again, my questions, if there are any questions. Are there no questions? Okay. So let's see what else we could reasonably take a look into, since I don't want to start anything new as it's already quite late. We only have 15 minutes left. What would be a good thing to do? Well, from this library we already have all the interesting things. Yeah, I think from this library that will be it. What we could take a look maybe into is this graphical UI designer, because it has quite a few different abilities and many different widgets that can be used. So let's quickly start a new project for that. Actually, we could use our existing Qt UI test. Don't need to create a new project. Okay. So as you remember, this thingy was implemented mostly as a text editor, but let's slightly improve on that. First thing we could add are for example, tabs. So by default the tab controller is created with 2 tabs, and you can switch between them, and you can place control elements on either of them. Like with a widget, you need to select some basic layout. For this, for the second tab, we also will select a grid layout. But we need first to add something to it. So what would be interesting? We could go, that's actually nice, with a tree widget. Tab layout, grid layout, and of course we can add multiple pages. So you just can right click on the tab and then add. So you can either erase the pages or add additional ones, as many as you want. You can do this also programmatically from the C++ code, of course. So for example, one could change these examples such that it would be able to open individual documents in different tabs and add a new tab each time it opens a document. So that is something that might be an interesting improvement, but for now let's quickly look what other control elements we typically have. So as you already I think remember, we have this push button, which can be just used to start some action. And another thing which is quite useful are the spacers, because they allow you to define where you want your layout to expand, such that other elements would stay small, as you see here. Then we have another type of button called the tool button. It is quite similar to a push button. It just doesn't have a default width, so it always collapses to the minimum available size. but it also has other functionality, as for example you can add a menu to a tool button. So you might remember from older programs that if you have a toolbar, then you might have buttons which have a small arrow on the side, which then open a menu with other options, and this is something you can add to a tool button, although you would need usually to do it programmatically and not through the creator. So it's a bit the creator is, as already mentioned multiple times, it's fast and convenient, but it is slightly limited in what it can do. The other type of button is a checkbox, and here's a checkbox and a radio button, so both are technically derived from a QAbstract button, and they have the same signal, so click, toggled, etc. We could quickly run this to see the difference. The main difference is that that if you have checkboxes in a widget, you can select as many as you want, while with a radio button the default behavior is that you can only select one of them. Normally you are putting them into radio button groups in order for them to know which one is allowed to be selected. Here, since we don't have a group, they are all just in one top group and you cannot select two of them. While with the check buttons you can select as many as you want. And about selecting for the button itself, you can set the there is a property that checkable. You can set the checkable property, which will change the button into a toggle button. Also for checkboxes, as you see, this is by default always checked since it's a button, but there is also a restate option. We'll see what it does in a second. So let's run our example again. So first of all, our push button, it does not look much different, but it technically can be toggled. It is just not graphically. It didn't save anything. It didn't apply anything. Let's try compiling it again. As you might remember at the beginning of the lecture, we also had the problem that we did some changes in the editor and it did not took them. Yeah, now it's working. So you see the button, it kind of has one layout when it's not pressed, another layout when it's highlighted. When you press it, then it now stays pressed. This is because it is now checkable. So it basically behaves like a checkbox, just that it is graphically completely different. And talking about checkboxes, as you see, this one or the radio buttons can only be marked or not marked. You can also have a three-state checkbox, which starts out with this semi-checked state or intermediate state or indeterminate state. Depending on which framework you are using, they are referred to differently. And the initial idea of this third state for a checkbox is if you for example, show properties of some objects, and some of the objects have properties set to one value and others have the same property set to a different value. So if you have checkboxes, then how would you show it to the user that for this particular parameter the values of the selected elements are not uniform, and this is used, and this is what this indeterminate or intermediate state is used for. And generally the idea is that if it's in this state, then whatever is done, it will not change the state of the elements, but if you change it to either fully checked or fully unchecked, then this state will be applied to all the elements. Of course, this is just a convention. You can use this in the intermediate state for whatever you want. So for example, if you have a function which can be enabled or fully enabled or half enabled or not enabled at all, then you could have like fully enabled checked state, half enabled semi-checked state, not enabled unchecked state. So as said, it is up for the up to the user to decide how to use it. But generally, if you want to do it in the way that is recommended for such options, so you would not want to confuse your users with, okay, and what does the intermediate state means? So what you do usually is you are using a combo box instead. The nice thing about combo boxes is that you can add values like, I mean, here we will just use the same values as the radio button would have. and one-shot partial fully checked. And first advantage of a we didn't save it, damn it. Save. The first advantage of this combo box is that it describes exactly which option is doing. Okay, not in this case, but if this would be functions, then you could kind of write fully enable function XYZ, enable only basic implementation of XYZ, disable XYZ. And so that's the first advantage. And of course the second advantage is, as you have probably already noticed, is that you can specify as many entries as you want. So it is not like limited to just having 3 states. You can have 4 states, 5 states, 10 states. There really is no limit. Of course, at some point, if there are too many, then scrolling becomes tedious. So it's usually good practice to not have more than maybe like this much. So about 10-ish, 20-ish entries. If you have more than this amount of entries, then what is recommended would be to use a list box. List widget. We can make it bigger. So as you noticed here, we can assign how many cells we want our list box to take, and we can here again add as many entries as we want, but given that they are then all shown at once, it is easier for the user to select something. And what also is we didn't save again. And what also is advisable with such lists is to offer the user a search option. So for example, an additional text entry line edit either on the very top or on the very bottom, where if he starts typing, then the selection within the list will be restricted only to entries which match this search term. Unfortunately, Qt does not offer any built-in solution for that. So if you want to be good to your users, you would need to implement such things manually. The good thing about C++ and its ability to derive objects from other objects and so on is that you can create, like, for example, a my searchable list, which would be a widget which would contain a simple vertical layout made out of an actual list widget and a text edit, and then you could implement all the functionality required inside your new class. And if you derive your class from a QWidget, then you can just insert it into the Qt UI that you create. For example, you could actually even have a code that looks for all instances of QListWidget and replaces it with your specialized list widget. You could even make it such that your implementation of the searchable list widget takes a normal non-searchable list widget as an argument for the constructor, such that it even maintains all the options which you have pre-selected here. So if there is interest in such a trickery, we could take a look during the next lecture on this and implement maybe our own searchable something. But for today we don't have enough time. So let's just continue taking a look into what other things we can, what other useful widgets we can add. So we had push buttons, lists we had. Another quite interesting element is this already added here, tree view. A tree view basically is something like what you see here, just that the way Qt implements a tree view, it kind of allows you to have multiple columns. So unfortunately, I think without any without any payload, it's not so easy to demonstrate. So maybe we just create some payload in the C++ code quickly for demonstration purposes. So UI punct header set what was set was it set header labels? Header set. Right, so we have our tree, we have our header. We should be able to now add this tree view layout. Header. We have our header. On this we should be able to define which header labels we want to have. For some reason it does not. One moment please, I will quickly check what was the function to set the headers for on that. Should we set header labels? Actually it should be on the tree itself. I know why. I think I added the wrong element. Which one is it? Tree view. They are like from the list and the tree. There are tree view and tree widget. And the tree, only the tree widget allows you to easily add header elements and stuff like that. The tree view requires a much more sophisticated approach of adding elements. Set header labels. And form. Okay, so on the top level we have to use add top level item called widget item and before we add it, first we should give it some text. Save text. You can specify the column, so the first column will be, let's say, the first column will contain one. I'm not particularly creative with the examples here, but I don't have to. We just want to see how it works in general. And on any item we can have add child. So we will do a second loop, just with a different loop variable, and we can copy this. Just need to rename the variable here. Sub item item add child sub item, and we can run it to see how it will look. And as you will see is that it will create you a really nice view with so we have our top level items. What is grab? Oh yes. Let's quickly fix that. Zack, play. Okay, so we can set text for every column, and then we can open our elements, and they have their own child elements. And in principle, a child element can has its sub-child and so on. So you can have an arbitrarily deep going hierarchy of elements, and that's that. One thing that is probably worth mentioning is that the way it looks here is not necessarily the nicest ones. I mean, it looks like modern Windows, but I really don't like that. So what we can do is we can change the style. How was that? Q style factory. Create. I think it's called just Windows. At some point it was called Windows XP, then they have redid it, changed it. and it kind of yeah. And now what you see, it instead of this ugly small arrows and no lines, it is much nicer, because now as you see it shows you actually lines from one element to the other. What you also could do is, of course, you could set icons. Unfortunately, I don't have an icon here to demonstrate, but what I could demonstrate is to add another level of sub items. Okay. Oops. Sub item 2, sub item 2. Oops. Sub item 2. Okay, so now we have just added another level. Zack. And especially when you have a lot of elements, I find these lines quite helpful in seeing how the things are organized. But as I said, it's up to you. You don't need to use this style. There are also quite a few other styles in Qt. Well, quite a few is maybe an over-exaggeration. There's kind of one which is available on every platform. And the other says, like, Windows is only available if you actually have, if you are running on Windows. If you would be running on Mac, then that just looks pretty much the same like the non-Windows version. But there's another thing we could actually do. We could change the complete style of our entire class to Fusion. Then you will see that it looks a bit different. And the idea is that this... What is it? No, it's not. Did I mistype that? I think it was called Fusion. Maybe it is case sensitive. Two things. First of all, application. We'll set the style for the whole application. That's one thing, and if it doesn't work, then we will try large F. Maybe it is case sensitive in the end, but that would surprise me. Yeah, now it worked. So you see, well, you don't. It's not easy to see. Let's make a screenshot and then see a comparison side by side. The nice thing about this Fusion style is that it is available. It is platform independent, so on every system, if you are using this Fusion style, so this is the not Fusion style, that's a normal modern Windows style. Zack. Then we will quickly enable our Fusion style again. And when you compare, it is similar but not quite. The buttons are more rounded. The behavior when marked is quite different. The checkboxes look slightly different. Yeah, it's not a big change, but it is a subtle change. And for example, this corners here are a bit rounded. And as I said, this style you can have on every platform that you compile your program for. So whether you compile it for Mac, for Linux, or even for Windows, you will get the same, the exact same look and feel of your application. Also, if you want to implement things like a dark theme or something, this is actually quite useful, since the Windows's own control elements are not that easy to properly theme. Some of them are a bit hard-coded, so you cannot change them in any way you want. Okay, I think this is enough for today, since we are already over time, given that we didn't have a break of any sort. Then let's stop here for today. If you have any questions, you can also ask them by email. Next week there is a holiday, so there will not be no lecture next week. We'll hence meet in 2 weeks from now. I will upload the recording and the QVT test to Moodle. I think this is not necessary, so I will not upload this unless anyone wants to. Well, and that's that. So have a nice weekend. Bye bye.